All right, the first thing you're going to need to do with any of these energy diagrams is to figure out what temperatures you are dealing with. In this problem, I am going from 20 degrees and I'm going to where it is all boiled away. I do expect you to understand that it all boils away at 100 degrees Celsius. So we are going to be starting from 20 and we are going to be going up to 100 degrees. I also would mention in this problem that I am boiling away. Boiling away means that it is undergoing a phase change of a liquid to a gas. So that is where I'm going to see a flat line on my diagram of where it is undergoing that phase change. But in order to get up to that 100, I know I'm going to have to increase my temperature from 20 to 100. So looking at this graph, I know that there are going to be two math equations that I'm going to have to use. The first one that I'm going to deal with is this initial heat increase or temperature increase to go from 20 to 100. So to go from 20 to 100, I know I'm going to be using my formula Q equals MCAT. In this case, Q is my energy, is what I'm trying to solve for. So that is going to be my variable. My mass in this case is 450. My C value is 4.18, and that you can look at your constant sheet for water. My delta T is always going to be final temperature minus initial temperature, so it's 100 minus 20. In the end, I end up getting 80 degrees Celsius as my temperature change. When I multiply all of those out, I end up getting that it took 150,480 joules to increase my temperature 80 degrees. But I'm not done because what I need to do now is I need to figure out how much energy does it take to go and convert all that liquid into a gas. So when I'm doing that liquid to a gas, I know I'm undergoing a phase change, which means there's no temperature change, which means that I'm going to be using the formula Q equals HM. In this case, once again, I'm solving for Q. So my H values, I have two of them, vaporization and fusion. This is by definition vaporization. So I am going to be using that one, which is 2,260. My mass has not changed, so it still is 450 grams. And when I multiply that out, I get 1,017,000 joules. In order to figure out my total amount of energy, what I now need to do is add up both of these numbers. And what I end up getting is 1,167,480 joules. That rounded to the 2 sig figs from the problem is going to be 1.2 million or 1,200,000 joules. But it asks for the answer in kilojoules. So I'm going to do a really quick conversion where I know that it's 1,000 joules for every 1 kilojoule. The joules cancels out. I'm left with kilojoules. So putting that into my calculator, I end up with 1,200 kilojoules. In order to figure out if it's endo or exo, what you need to do is I look at my overall temperature change, which is increasing. As a result of an increasing temperature, that means you have more energy because energy is directly proportional to temperature. And so therefore, because it increased it, it had to absorb that energy. So therefore, this is an endothermic process.